Hello students. Now we are going to discuss a question of CBSE 2019, which is an NCERT model question on a concept of electric fields. The question we are given with here is an electric field is uniform and in the positive x direction for the positive x and uniform with the same magnitude in the negative x direction for negative x. It is given that the value of E bar is 200 I cap Newton per coulomb for x greater than 0, that is along the positive x axis, and the field is minus 200 I cap Newton per coulomb for x less than 0, which is along the negative x axis. A right circular cylinder of length 20 centimeters and radius 5 centimeters has its center at the origin and its axis along x axis, so that one face is at x is equal to 10 centimeters and the other is at x is equal to minus 10 centimeters. Now what they're asking you here is, what is the net outward flux through each flat face? What is the flux through side of the cylinder? What is the net outward flux through the cylinder? What is the net charge inside the cylinder? This is a question which is based on electric flux also. We have this concept of electric flux. Now the diagrammatic representation is as shown in the figure. For a cylinder, they have given length of the cylinder to be equal to 20 centimeters, and exactly at the center of the cylinder we have the coordinate system x axis, y axis, where half of the system is towards the left, that is along the negative x axis direction, which is at a distance of minus 10 centimeters. The other one is at 10 centimeters of the cylinder is along the positive x axis direction. In this case, they have given the radius also, which is 5 centimeters. Now, what they are asking you is, here they are asking you to calculate what is the net outward flux through each flat surface. Here there are three surfaces for the cylinder. This is one surface, this is the second surface, and this is the curved surface. These two are the flat surfaces. So now we are asked to calculate what is the flux through the flat surfaces. Is the first question. The second question here is, what is the flux through the side of the cylinder? What is the flux through the sides of the cylinder? That is this curved surface. If you consider this curved surface of the cylinder, what will be the flux through this curved surface of the cylinder? And also what they're asking you is, what is the net outward flux through the cylinder? What is the total flux through these three surfaces which are forming as an enclosed structure, which is a cylinder? And also what they're asking you is to calculate the net charge inside the cylinder. So if you observe, in this case the electric field is positive along the positive x-axis direction, negative along the negative x-axis direction. So these two flat surfaces have area vectors. Area vectors will always be perpendicular to the area. This is the flat surface area, so the area vector will be delta s bar in the positive x-axis direction. And here in this case, this one have the area which is delta s bar along the negative x-axis direction. See, this can be solved using two formulas, which is flux phi is equal to E bar dot delta s bar, or you can make it as flux phi is equal to E into delta s cos theta. As in the question we are given with vector representation, instead of using this formula, because we have to know the theta value, instead of using this, we use the dot product method. Without knowing the theta also, we can calculate the flux through each surface. So going to that, first we will solve the first question. For the first question, what we have, first surface we take the left surface. On the left surface, or for the left surface, if you take on the left surface, what are we given with? First we are given with the field which is E bar is equal to minus 200 I cap Newton per coulomb, and here area vector delta s bar is equal to magnitude is delta s minus negative I cap, because it is along the negative x-axis direction. So from this I can write it as minus of pi into r square is the area of cross section here. That is pi into r square means r we are given with r is equal to, we are given with 5 centimeters. which is equal to 0.05 meters, and length L is equal to, we are given with 20 centimeters, which is equal to, we can write it as 1 minute. Length is given, L is equal to 20 centimeters, which is equal to 20 into 10 to the power of minus 3, sorry, not minus 3, it will be minus 2 meters, which is equal to 0.2 meters. Conversion of the system of units to singles, which is SI system, which is meters. Now in this case, what we are supposed to calculate, first we will calculate the area in the case of the left surface. So it will be 0.05 whole square I cap meter square. Now the outward flux is how much? The outward flux through the left face, is flux due to the left face is equal to, I take it as E bar dot delta S bar, which is equal to, E bar is to the left surface, it is minus 200 I cap. So minus into minus, I can write it as plus. So I take it as minus 200 I cap in dot. We can write it as minus pi into 0.05 square I cap. So in this case, minus into minus plus, that will be 200 into pi into 0.05 into 0.05, which is I cap dot I cap, which is equal to, and multiplying all of this, what we get is 1.57 Newton meter square per coulomb. Why? Since the dot product of any two vectors, which is I cap dot I cap, will always be equal to 1. Next, this is due to the left surface. On the left surface, this is the flux, which is flux due to the left surface. Now we are going to calculate the flux on the right surface. On the right flat face or right face. Here, for the case of the right face, we take the field to be E bar is equal to 200 I cap Newton per coulomb, and delta S bar is along the positive x-axis direction, so which is delta S into I cap, vectorial representation we are taking, which is equal to pi into 0.05 square I cap meter square. Now the outward flux through the right face is flux due to the right face, which is phi r is equal to E bar dot delta S bar. Simplifying this here, again I'll get it as substituting the same values again. So it will be 1.57 Newton meter square per coulomb. So this is the flux due to the right surface. And there is one more surface, which is flux due to the curved surface. Flux due to the curved surface. Again, you can take it as the side of the cylinder. In this case, what actually happens is field and area vector are perpendicular to each other. Remember, whenever we have the field and the area vector, here in this case also the field is along the positive x-axis direction, which is E bar, and the area vector is also along the electric field. So in this case, the angle between these two, which is electric field and area vector r, is 0 degrees. Cos 0 is 1. So we have flux here. And in this case, here again, we have taken both of them along the same direction, which is delta S bar and E bar. So theta is again 0 degrees in this case also. So we have taken the flux to be cos 0, again 1 you will get. But here in this case of the curved surface, if I take any area vector, a small ds area I take, and at this point the field will be in the positive x-axis direction and the area vector will always be in the perpendicular direction. Remember, area vector will always be perpendicular to the area. In that case, for this whole curved surface, whatever we are considering of the cylinder, you have the area vector perpendicular to the direction of the field. Hence what happens is the flux due to this curved surface will be equal to 0. The flux due to the curved surface will be equal to 0. Now what else they are asking you? This is the second part of the question. This is the second part of the question. Now the next, what is the outward flux here? Outward flux. Here, flux being a scalar quantity, total flux or total outward flux phi is equal to phi due to left surface plus phi due to the right surface plus phi due to the curved surface, that is flux due to the curved surface. So total flux is equal to 1.57 plus 1.57 plus 0, that is total flux is equal to 1.57 plus 1.57 is 3.14 Newton meter square per coulomb. This is the total flux due to this cylindrical surface. Along with this, they are also asking you to calculate the charge enclosed. So the net charge inside the cylinder, the net charge to be calculated here. The net charge be Q. Here we use Gauss law. Using Gauss theorem, which is flux is equal to charge enclosed divided by epsilon naught. Flux is always equal to charge enclosed divided by epsilon naught, that is flux Q, charge Q is equal to flux into epsilon naught, which is epsilon naught is the permittivity of vacuum or free space or air. So flux phi is known to us and epsilon naught value also we know. So that is 3.14 into 8.854 into 10 to the power of minus 12. So simplifying this, I get charge enclosed is equal to 2.78 into 10 to the power of minus 11 coulomb. This is the net charge that is enclosed by this cylindrical surface. This is the flux due to the curved surface is 0, that is the flux due to the sides of a cylinder is 0, and flux due to the right side surface, which is the flat surface, is 1.57 Newton meter square per coulomb, and the flux due to the left side surface, the left side flat surface, is again 1.57 Newton meter square per coulomb. Hope you understood this answer. For more such questions, please do like, comment, share and subscribe our physics channel. Thank you very much.